So good morning, everybody. I'm Rahul Singh, and I'm with the Anant Corporation. We are doing this CIO, CTO training for Docker for a couple of reasons. Primarily because when we have to teach something, we have to know it better. And this is one of those technologies which is transforming the world. And I've had the great pleasure of creating a knowledge base, which I'm going to be sharing with you. It's on GitHub. So I like it because of that. But also from a business standpoint, and actually Tom mentioned this earlier, we are identifying how to help larger companies transition to being a more modern enterprise. And Docker is one of those tools. So just interacting with folks helps us understand the market a little bit better. So there's a little bit of selfishness as well. But at the end of the day, it is really about the people. We get to meet really sharp and awesome people. Whenever I've done a training, I've done different types of training in our office before. And so thank you for coming out. What I'm going to start out with is just a quick outline of the agenda. We've already helped people get their stuff together earlier, but if you are going to do the hands-on portion, please make sure that you have the prerequisites installed, as they are part of the site Eventbrite instructions. I also believe I sent out an email reminding you guys to get those installed. And just make sure that when you run Docker run hello world, that's more important that that works. And it says that, hey, this worked. Okay? And so everybody here is on their way or has already gotten the Docker run hello world to work? Okay, good. So looking at Docker, what I want to first show you is a container running Docker for the knowledge base that I've built for this class. Okay, this website is hosted locally, and for those that are using boot to Docker, you will see an IP address. For those that are using something else, it'll be on localhost. But essentially, this application, it's a Node.js application. It reads markdown files from the local file system. It's been mounted, so I can edit these files, and it serves it up. Okay. Now, the software itself is just the image. It's somebody that has published a container. All I'm providing is the data. And I did not have to install Node. I did not have to install all the NPM packages. Okay? All I had to do was say, Docker, run this container, here's my data. And it sucked it in and made it happen with one line. And you guys will do the same thing. You will clone this repository and you will run the same thing. But that same instruction set that I use to run it on my local computer, I can actually send it to a cloud provider like Amazon, Google, Microsoft Azure, Rackspace, DigitalOcean, even Heroku supports containers now. All of them, I could essentially send the same instructions and it would publish this site to the internet. Okay? So this is one of the things we're going to do in the hands-on section, is you will pull this repository down and you will run it. Okay? Yeah, go ahead.
Yeah, when you say an image, what is that?
We'll cover what an image is, and we'll cover the terminology in a second. Okay? So I'm going to use this knowledge base to go through the materials. Okay? If you are curious, and while I'm going through it, if you would like to know where it is, I'll Slack it on the channel. I'll just Slack it. Okay. And so far, my repository is exactly the same as what you see up there. Okay. All right. It's on topic Docker. And you can get to the Slack on your computers as well. If you just go to anantco.slack.com. ANTCO.slack.com. Look in your email. Everybody that is here got an invitation. Okay.
Yeah, I saw it yesterday from one like what's this?
So at the high level, large companies, when they are starting to use Docker, Docker is one part of the whole toolkit for scale. It is a delivery mechanism. It's part of the reason why it's actually called Docker. Okay? It's because they have figured out a way to contain software in a standard way and ship it from one place to another. Okay? So just a little bit about me. And then I'll talk about distributed computing. We'll talk a little bit about Spark, Cassandra, and Kafka, because these are reactive technologies that are out there today that can scale with the needs of an organization. And then finally, we'll talk about how Docker can help scale these type of solutions. So I actually built a hosting company back in the day in 1998 and grew that, designed a data center, got out of that business. There's actually some old rack mount servers in the back here that I probably haven't turned on in 4 years, 3 years, because we did play around with some big data technologies on there. Then I got out of that design. After designing the data center, I pretty much figured I was out of hosting, but we started consulting and building scalable applications. What people used to call application service providers would hire us to build their software and then to run it. Right? People call that software as a service now. And then I have done IT consulting with big agencies, big firms, small agencies, small firms. And today, I do management consulting for internet teams, and we help people deal with difficult data. That's one way to say it, where really what we're trying to do is get people's stuff together. They don't understand how to move things to the cloud. They don't necessarily know how to change their team to adapt to the modern enterprise. But that, when we talk about data, a lot of times we're running software, different pieces of software for different companies. We were exposed to Docker because we were playing with it, but then eventually we started to do work in, let's say this is an ETL process, essentially, the data processing process. And we recognized the power of Docker because we could move or replace certain components of this diagram with different pieces of software, but yet have the same framework. And all we had to do was adhere to a standard and just replace one Docker container with another. So I look at this stuff as how can it help with business information? Okay? Like consumers aren't going to be using Docker for their personal information, although some enthusiasts do. Ultimately, from a business standpoint, we'll have to come back and say, how is it actually helping the business? Is it helping the CTO make more money for the company? Is it helping the CIO make more profit for the company? That's the major difference between a CIO and CTO. Yeah, their titles are different, but a CTO is supposed to increase revenue, and a CIO has to make the organization more efficient. Well, ultimately, it comes down to the information, the business information. How does it actually show that from a measurement standpoint?
So CTO trying to increase profit, whereas CIO makes it.
No, CTO is responsible for customer-facing technologies.
Okay.
So they are basically in charge to create new revenues or increase revenue. Our CIO is responsible for the operations technologies.
So CTO is external, CIO is internal.
Exactly. Excellent. Any questions, any clarifications for that?
So Docker is pretty, everybody jumping on Docker, and it looks like it's going to take off really well, and it's going to be the future. Do you see anything else that is, coming around the corner that might take over Docker, or is it?
I think from a container standpoint, the standardization, there's different types of container technology. Docker is not the only one. In fact, there was a fork from Docker, and it's called Rocket. Okay, it's a little bit more streamlined. They had philosophical differences. If somebody wants Docker to run 5% faster, they may go to Rocket. Okay, but in terms of the widespread standardization across different clouds, once companies like Google and Microsoft and Amazon can agree on one standard, I doubt something else is going to replace that. But then again, the way we write software may change in 5 years, and it may get replaced. But there's a certain fog of the future that we can't see beyond.
Sure. I mean, I only ask it because limited time, and I just want to know whether we're investing the time in the proper technology.
If you one of the things, one of the slides I'm going to refer to, Docker has had billions of image downloads, meaning people are using Docker to run billions of containers. Google runs their whole infrastructure on Docker. When you go to Google Drive, they spin up a container for you and your collaborators. And obviously it saves data back to persistent storage, but once you're done, after an hour, it kills the container. That's how Google runs. Okay? So if Google is running on it, then at this point they've invested heavily.
What about
Amazon has, Microsoft is running most of their apps on Docker. Yeah. Amazon is in a different business where they sell their own machines, but they also offer, I don't know architecturally if they moved stuff to Docker. Yeah. So the phases of business technology, I didn't create this diagram. I would love to take credit for it. I just put the icons together. This comes from a book called Enterprise Architecture as Business Strategy. It's a Harvard Business Press book. Highly recommend it for enterprise architecture as business strategy. And I highly recommend reading this book because it talks about different types of organizations. And yeah, I'll type it in Slack. Yeah. And I highly recommend it because it's good for software professionals that are in the midst of creating business software. It's great for officers, executive officers, operations officers. Why for them? Because if they grow their business, they need to understand how technology will change as they grow. Okay? But the 4 phases of technology that book talks about, and there's a 5th phase, are business silos. You guys can all understand where, when you start a company, or when it's a new company, or if it's a young company, or if it's just a really poorly run IT shop, they just have software running on machines, right? Oh, we need a QuickBooks server. Oh, we need a SQL server for this, right? Or even if it's a modern enterprise, what I say is a modern enterprise, they have a Salesforce subscription. They have a QuickBooks.com subscription, or an MySAP.com subscription. It may be all in the cloud, but they're still silos. They're not connected to each other. Every business starts off with silos. Actually, it doesn't make any sense to integrate it unless you have silos. Like, what are you going to connect? What processes are you going to connect? Eventually, people figured that they have to standardize. So what used to be, okay, we're going to standardize on Microsoft, or we're going to standardize on Oracle/Java. That decision has changed to, we're going to standardize on our version of the internet platform. We're going to use React at the interface layer. We're going to use, let's say, .NET at the API app layer. We're going to use Cassandra and SQL Server at the data layer. And we're going to use Docker for the system layer, for example. Or we're going to use AWS for the system layer. Or we're going to use Azure for the system layer. That standardization is no longer one size fits all. You have choices today because of the internet. Docker is actually the easiest way to standardize because you don't have to choose the underlying hardware, cloud, data center vendor. Your developers don't have to make any changes for code that's running on their Mac to code that's running on a Windows laptop to code that's running on Azure Cloud. So Docker can be a great tool in getting you from business silos to eventually an optimized core, where systems are actually talking together. That's the goal of data warehousing, to bring the stuff together in one place so that there's a system of record. Master data management is one of those terms that people use. Once people have an optimized core, then they have the ability to be modular from a business standpoint. they can acquire a company and connect it to their internal core. But they have to go through these stages. It's yeah.
What you're referring to is thin client services. For example, if I say SQL Server 2016, it's a complete module. But when I say SQLite,
Yeah.
what you're saying in terms of modularity is all the light services to be combined together in one container to be deployed as a single individual VM.
Well, optimized core, it actually works with the standardized platform. Optimized core is more on the information layer, meaning you may have SQLite on your mobile devices, but you have a process to synchronize back and forth from your core database, for example.
Okay, so the core is like what container is the core? Is it the operating system level core, or are you talking about the binaries that compose it?
No, optimized core is like the business core.
Okay.
The business core. Where is the information? Okay. Is there a logical separation of data warehouse and operational databases and analytical databases? Okay. Having one basically master schema of the whole enterprise, right? People don't even know where their information is sometimes, okay? But it happens because you have a standard platform and you can start to actually bring stuff together, okay? So there is one other phase that's not here, and that's business-to-business modularity. And business-to-business modularity is when you're using a set of software that allows you to work with another company and act like one company for the project, and then disband, and then work with another company or other 5 companies, and then disband. So the idea of nimble businesses forming and breaking apart for the purposes of engagements, okay? That is possible today, and a lot of people in the knowledge work industry, they do this. They freelance, they get small projects, they get together on Basecamp, they get together on Trello, but they happen to do it in a new way every single time, okay? Actually, that's a space that we want to be in. Our company wants to be in the space of making software that makes that happen. But that phase is not here yet. We're going to focus today on Docker, how it can help. People have this disconnected cloud. They don't have their stuff together. So basically, the thing that we work on from a research and development standpoint is getting information into one place so that people can find, analyze, act. And each one of these components is software. It's a search interface. Okay, it may be written in Angular 1. It's backed by an Elasticsearch index, which is populated by a process which is .NET, which uses a SQL Server database for its staging data. Okay, analysis, BI. There's a Java application that talks to relational databases, which then is populated by processes that may be in Python or Spark. So each of the things that we try to solve has a software development and a software deployment challenge. And this is why Docker has taken part over our life. Talking about scaling, right? What's the pro and con of distributing?
Excuse me, can I have this slide back? Is that something you're going to do with something?
It's part of the knowledge base. Yeah, it's all part of the knowledge base. So why distribute everything? Why separate out all the components, not run it on one computer? There's some software architects in the room. Well, why would you distribute stuff?
So you can leverage the scale and break down the job and run it together, aggregate it. Do things, leverage your infrastructure.
To do more. All right? All right, go ahead.
Scalability.
Scalability? Well, that's what it is, right? It's scale. But what type of scale is it? There's different types of scale, right?
Vertical scale.
Disaster recovery.
Disaster recovery is another reason. Okay. Business continuity.
What about like ease of like upgrade, you decouple things so it's easier to do
Replace
multiple
things. Yeah, maintenance.
things,
Easier
right.
to maintain. Saves time.
Right.
Saves time and money.
Big chunk.
Yep.
You got to touch every component.
Yep.
Like GitHub stuff like that. You just pull the repo that affects the
Exactly.
one component.
And
Doesn't
rebuild
affect
that.
the other one, right? Yeah.
And rebuild that part of the infrastructure, right? There are some complexity issues, but what you invest time and money into makes life easier, right? Now, you guys may have seen this, but when when I was growing up with technology, people used to say, "Oh, I'm going to make a new operating system." It's like, why would you make a new operating system? Why waste your time? Well, today I hear stuff like, I'm going to host my own project management software. And up until Docker, that was a credible way to make fun of somebody. Why would you waste your time hosting something? It takes so much effort to bring up database servers and application servers and content delivery networks and proxies. Why would you waste your time? Well, today it is a lot easier. It is actually as easy as using a software as a service. So you could make that choice today. You could be a big company and not want to give your chat messages to Slack or Microsoft Teams. And you could host Mattermost, which is an open source chat program, just like Slack. Okay. But self-hosting, what used to be a maturity in self-hosting, now is actually the maturity. Being able to say, I'm using these software as services that are external and public to us, but we have decided to store these things internally and have the same level of maintainability and uptime as a software as a service or a platform as a service. Okay?
So how do you explain this to us? Because a lot of CTOs and CIOs have bought into the idea that, okay, you know what, they're handling it, we're going to just, let them handle it. Now we bring it back into their platform, and they need to sort of maintenance. So how do you explain that?
That's a really good question. It is actually, it all comes down to what's in it for them. Okay? So when you're using a software as a service, what are the benefits of a software as a service? It's hosted, somebody's taking care of it. It's a flat fee per month. When you're hosting something yourself, what are the benefits? Have control, security of information.
Yeah.
Okay, what else?
Well, security is debatable because.
Debatable. Security.
If you did,
you know your
what's that?
You own your own library.
Control. It all comes out of control.
Yeah.
Configurability, customizability, control.
Yeah.
Right? Okay. So with doing it on Docker, you actually get both. Because there are people that are now certifying, well, Docker will certify images. We'll talk about images in a second.
Okay.
Where you can buy it. You can pay a license fee for the Docker image where there's a company supporting it. But it's running on your hardware. Right? Just like Amazon Images, you know how you can pay a support fee? You can get for AMIs? Yeah. Similarly, you can basically pay for licenses of certified Docker software.
It already has things on it, everything you need.
Exactly. You don't necessarily have to manage the hardware, right? If you use ECS or ACS or GCS, right? Elastic, Azure, or Google for this, you're just pushing your configuration of what you want. So you're getting basically the best of both worlds in the cases where you need it. It's not that you're going to replace every software as a service, but the places you want control, you could say, we will just run a Dockerized version of this.
Okay, I'm not understanding the truth of it. Maybe you can help me explain it. So you're saying, so when I understood the part of, bringing backing and having control and customizability,
right?
Then you're also you're saying that part of it is you're still letting host it on data centers, which is maintained by
But you have a large degree of control there. You could run that container on your hardware in your office. You could run that container on a EC2 instance, meaning not even part of the container service. Like it's in your virtual private network, which has no incoming traffic at all right? Or you could basically do it on their large container service. That's where you have the control of deciding where you want to be.
So you have more options.
Yes. It ultimately comes down to having the same kind of, it's not changing because somebody made this piece of software and I'm running it and I maybe or may not be paying for support, but then having, like the knowledge base, when we look at the code, I didn't make the software. Somebody made the software and made an image. I literally just said, use this image, use my data. It's one line of code. And I can run it here or I can run it on Amazon. I can decide to pay for it on Amazon, or I could run it on a local old, rack mount server and just give access to people here. But the maintenance is basically my content, which I would have been doing with software as a service anyways, right? So I feel that it's a best of both worlds. It's like in Cassandra, you have tunable consistency. I would say with Docker, you have tunable responsibility. You can decide how much responsibility you want. Okay. Yep. So Kafka is one of those tools which a lot of people are starting to use. It's a difficult tool to understand sometimes, but with Docker, it's easy to start putting it into play. If your software may end up scaling to billions of operations, okay, or millions of operations a second, you may want to think about Kafka. Well, to prototype with Kafka, you need to have a zookeeper ensemble, and then you need to have a broker group. You need like 2 or 3 computers. Like, forget that. All right? I don't want to deal with that. Who wants to deal with that? But let's say you prototype your software with Docker, and then it starts to grow. That, bless you, that prototype could easily translate to a much larger, and we'll see this at the end, it can translate to a much larger infrastructure because the same exact code will work, whether it's on one laptop or it's on 50 computers. Spark. Actually, Spark is pretty easy to get started off with in one node. But what if you want to prototype a Spark process which is actually, running with 5 worker instances? And you want to see how well the work is getting distributed, okay? And you want to prototype it. Beyond prototyping, you can be 100% assured that you can bring up a Spark process, run your job, and destroy it. So think about that. You are going to be only paying for the computation time. And yes, technically you can do that with elastic MapReduce. You can say, give me 10 computers, here's my Spark job, it'll do the job, it'll be done. Or you could do it with Docker.
But what do you do in the load balancing?
Oh, Spark does its internal.
It's a dynamic algorithm within itself.
Spark has a way to, well, you can in the code itself you can say repartition data, shuffle and stuff like that, but that's built into Spark. Yeah.
What's the guarantee?
Guarantee of what?
That you're done. There's nothing residual there.
So, in terms of data or the image, yeah. So, if it's your servers, you can say Docker remove this image, and that's one of the commands. You can say remove the whole image. Done. And on the ECS CLI, I'm pretty sure there's a similar command that says actually go ahead and remove it. Right.
Like a destroy or something.
Destroy. Yeah, it'll just delete it off the computer. Yeah.
In the previous slide, you had used Kafka and Concerto. Like, are they providing you support?
I think Confluent.
Confluent.
Yeah.
Sorry, Confluent. Yeah.
Yeah. They do provide support, enterprise support, and even in their tutorials they have like Docker tutorials. So yeah. Companies like, exactly. Companies like DataStax, Confluent, they're supporting their builds on Docker.
So that is like, DataStax used to be for Cassandra.
It is Cassandra. Yeah, DataStax is Cassandra. Confluent is for Kafka. Yeah. Cassandra, it's now one of my favorite NoSQL databases. It's being used at very, very, very large companies, which I'm not going to say because this is being recorded. When we have lunch, we can talk about it. But large companies that need to do, let's say, 500 terabytes of storage, and their data grows 15 terabytes a day, they need to use something like Cassandra. Well, the developers that are using it, okay, to properly do a good, testing on Cassandra, you need to have at least 3 or 4 nodes. And if you have a multi-data center set up, you need to have 2 data centers with 4 nodes each. Okay, that takes a lot of resources. Here's a place where you can bring up an instance on AWS or Azure. Forget the container service. Just bring up a machine with like 80 gigs of RAM, maybe 250 gigs of RAM. It costs $1.50 per minute. Per hour. Excuse me. That'd be very expensive.
You're contributing to his billion.
I know, right? Yeah, but it would cost about like 8 hours to do a good test. Okay, with like hundreds of nodes of Cassandra running there. So large technology, big data technologies, you could do it locally on your laptop, and then you could say, let's do a slightly bigger scale. And then when you go to production, you could have hundreds of nodes. In fact, Kubernetes, which is Google's orchestration system, if you look at their source code, one of their storage examples is for Cassandra. They have written some code specifically to say, I want 100 nodes of Cassandra. It'll spin up, it will broadcast all the nodes, and all of a sudden the cluster is bigger.
So basically it's for like a pre-processing of heavier data, but on a node level, basically forking.
What, Cassandra?
Yeah.
No, Cassandra is a NoSQL database, which is a columnar store.
Like cluster.
It has, it's clustered, but it's highly available. Yeah, it's a highly available database.
Every node in itself is a load balancer. Because it
Yes,
can generate
yes,
its own
exactly. And there's no, this is one of the best things about Cassandra is that it's master-master. If one node goes down, there's 3 other replicas, so it's fine.
Are you familiar with Hazelcast?
I am, yeah. There's an internal thing inside there. It's called Gossip, which is how this technology runs. Yeah.
So Cassandra is usually used for large data sets.
Very large data sets, but I think it's the best database to start into big data because you can bring up a computer and keep adding.
What about connectivity? Because at that point, if you spend it on the AWS, right,
Mhm.
you'll be limited by what you have between, like, if you're like multi-region.
Yeah.
You know, if you don't have like direct connect or something like that, that could be a bottleneck.
Yeah, that's the thing. You have to have different use cases for like what's your development environment versus what is your production environment. But if you truly want your own off-site replica, you can do that. You can have a Docker cluster locally and have heavy machines actually doing the Cassandra stuff in EC2 if you want.
Right.
Or you can say Docker everything.
Right. How does that compare to using like their own EMR, which is their service,
Yeah.
which has something in the back you
Yeah.
can control,
Right.
probably bigger pipes that they guarantee.
So the equivalent of Cassandra in Amazon is DynamoDB.
Oh, okay.
Yeah.
Those simple data. Oh, okay.
Yeah. It actually went further. It used to be called column families. Now they're called tables. And it actually looks like SQL. That's why big companies are moving to it. Okay? So,
DynamoDB is a comparable.
yeah, but you see a pattern here? These are technologies that would normally be reserved for extremely large companies. But you're getting to be nimble and act like a large company and have software run on the same technologies that essentially is powering the big companies.
Right.
And be able to do it on one computer to play with it and then to scale it. Yeah, go ahead.
Why would a small business be interested in these when they be really, really expensive to charge?
So normally, when you say small business, how big is a small business?
Like maybe, I don't know, tech startup, maybe like 10, 15.
Okay, so William said tech startup with 10, 15 people. If it's a tech startup, in today's age, they're probably going to be generating a lot of data. Okay, and they'll be processing a lot of data. So they were better off starting with something like this than to start off with something else.
Yeah, but how much does this cost?
The software, all of these are open source software, right? Yeah, all of this is open source software.
Okay.
Yeah.
Are you defining small business based upon number of people, or you defining it by market?
Well, that's why I asked him.
Audience.
His specific answer was 10 to 15 people, tech startup.
Okay, 10 to 15 people providing services on a global basis.
Yeah, the data footprint would be huge. Yeah, exactly.
Isn't scalability of the solution the cost factor?
Yeah, that's what it is. Yeah. Yep.
I'm sorry, so how did the Docker come in to make you this?
Yeah. Just to answer your question. So this is probably the most important slide in this deck, because this is where Docker takes all of those technologies which have the same exact pros and cons, okay, and makes the pros better, essentially, and actually diminishes the cons. All right? This idea of derivable images, okay? That means if somebody has published an image for Ubuntu, okay, I can say derive from, which is a keyword, from Ubuntu, apt get install, which is a way to install software on Ubuntu, Apache, and add my files to this container, okay? And then when I run that command to build my image, it checks to see if that image is already downloaded on my computer. Okay, when you guys did Docker run hello world, did you see that it was downloading all this stuff? Right? It was basically downloading different layers of images because the top layer of Ubuntu is the same on everybody's computer. Now, once it's cached or downloaded on your computer, the next time you need to build another image that derives from Ubuntu, it doesn't need to re-download it. It already has those files. It already has that data. So all it does, it says, what is different between the source, which is the image I'm deriving from, and the image that I'm building. So it's like object inheritance. Yeah, you're essentially, so here's a scenario. I have a company which has some use cases for Linux and some use cases for Windows containers. And you can do Windows Docker containers. It is actually running Windows without a GUI. You can do that, all right? But that only runs on Windows 10 and Windows 2016 right now. It's about to run on Linux. It'll be released soon. But let's say Windows, I have certain things I want to install on all of my Windows machines. And there are certain things I want to install on all of my Linux machines, namely security things, Kerberizing it, LDAP authentication. These things I want to make sure are on every one of my images. I could just say Anant Linux, Anant Windows, deriving from Microsoft Windows and Ubuntu Linux. Okay? Then everything that I build on top of deriving from Anant Linux or Anant Windows will always have the things that I said in my own image. Okay? So what happens if there's an update I need to make to all of the machines that have derived? All I need to do is update my Anant Linux and Anant Windows images. And the next time those images are built, the derived images, it will say, hey, there's a hash change. There's something that's changed. Let me go ahead and get the latest one. Okay? Now, it doesn't have to get the latest one. And when we go to Docker Hub, you'll see that some images have different versions. You can say, I only want Anant Linux version 0.1. Like that will be my versioning, you know? Okay? So you have the ability to do that if you want, or you can just say build the latest every time. This morning I was testing one of my Docker Compose files, and I realized I have a .NET Core image. It was out of date. The newer .NET has a different project format, and I hadn't run that container in a while. So I went in and I updated that part of it, and now it's fixed. But I could have prevented that. I could have just said use .NET version 1.0.1.
But how is your solutions not, like you must have moved from ASP.NET 5 to .NET Core.
Yeah.
And how did it not impact you?
So he said, how did it not impact me? Because I must have moved from ASP.NET 5 to .NET Core, which runs on all operating systems. So yes, this particular application was a .NET Core application, but you can run ASP.NET 5 apps on Windows Dockers because it has the full .NET framework.
Oh, because your core would have upgraded in all the other Linux boxes too.
Yes.
Really the Windows boxes.
Yep. Okay. Immutable containers. Immutable containers means that when I make a container, its file system is its file system. If I make a change to it, the next time I kill it and destroy it and restart it, it will start completely fresh. So from a security standpoint, that means that I could never introduce bugs into code on the system. The bug is there from the source. So if I make an image and it's running one way on my computer, it has to run the same exact way all the way through production. There's no way, unless you change the data layer, which is possible, right? You could say, get the data from my hard drive. Technically that's possible. So this is why Google keeps its data separate from their code. They have their persistent services that are always up and running, and that's how it is. And there's a debate whether to use Docker to do storage itself. Some people are like, no, use hardware to do your databases and file systems, but then just use Docker to run and destroy software. Okay?
So the image, once you create an image, then it's just immutable. You cannot change it no matter what I do.
You can stop it. You can rebuild it, rerun it. and then it'll be, destroy it basically.
Well, you don't change the LLM process. You have to change it from the source. So, meaning you want a new directory, so you have to do it from the source. I think that's what you're saying.
Yeah, I mean,
because if you change it locally and you redeploy,
yeah,
it will still go back to.
So yeah, so here's an example, right? Let's say you want to do development on a .NET app, right? And you're going to be saving code and you want to run it. You don't want it to be immutable at that point. So what you do is you say mount this directory from my hard drive. And when you make a change to your file system locally, it will show up in the system. But then when you're ready to push it, you'll have a different Docker file for production that says actually copy it from source control. Do a git clone of the branch.
So it's also does the version you want to create an image the next version.
You can tag it with a version. Yeah, I'm not, for personal stuff, I'm not tagging stuff. I'm just doing everything locally. Yeah. Another thing is composition. So composition means, and we'll go deeper into it from the technical side, but composition means that, okay, who's used WordPress here before? Okay, everybody's used WordPress. Okay, most people have used WordPress. What are the components it takes to run WordPress? And don't tell me GoDaddy $3.95 account. What does it take to run WordPress?
OS.
An operating system? Yeah. What's that? Okay. Well, I'm talking on the server side. So yeah, you got to have an operating system. Database, MySQL database.
Yeah, like a LAMP stack, something like
LAMP stack. So it's the system, MySQL, PHP,
right.
and Apache, or some even Nginx could work, right? Okay. So normally there's a set of instructions to build this WordPress, right? But what you can do is you can say my MySQL server is on, let's say, Amazon RDS, right? Relational Database Service. It's a persistent thing. They manage it for you. And you can have your production version on WordPress containers talking to that MySQL database. And you can have 100 different staging and development versions talking to a different database. But your system, your site itself is basically a composition of two containers, a MySQL or WordPress. And locally, you don't have to be talking to RDS. You can be talking to a dummy database on your computer, which is another MySQL container. So a composition is basically this service with this service with this service together. Everybody's using it. There's thousands of different Docker images already available. So you could say Docker run WordPress today, right now, and it will download and it'll run. And if you don't say link this to my MySQL database, it'll actually have an internal MySQL database that it'll bring up automatically. You could say Docker run Drupal, and it'll just run Drupal for you.
So it's pretty much you're bringing back Dockerization, bringing back reusability of multiple applications that go all over.
With a much higher abstraction of reusability.
Because you can derive and modify.
Exactly. So I could inherit from WordPress and copy over my WP themes directory and have my version of WordPress, right? My customization of WordPress. And I could then sell that as a software as a service. And some people do that. There are some landing page companies that essentially take the core WordPress and add their customizations. And so when new customers come, they just spin up a new container just for that customer. It's complete templating all the way through. Okay? So runs on Windows and Linux. It's been tested, definitely, with everything on Linux. I've tested it with .NET Core on Linux, and I've tested with legacy .NET, even SQL Server on the Windows Docker, meaning a headless SQL Server. Okay?
Sorry, can you speak a little bit about Windows?
Yes.
Version for a minute?
Yep. So the Windows version of Docker basically runs something called Nano Server, if you wanted to, or you can run the whole Windows Server core. Nano Server it's like back in the day, DOS, okay? But it's the latest Windows. And it only runs what you need it to run, like IIS, SQL Server. But it runs on a full-fledged SQL server, a full-fledged Windows server. So it has everything else it needs to run, And when we look at the architecture of the file system, you'll understand why it works. Because all Docker is doing is containing namespaces like the network, the drive, the memory. That's all it's doing. So I have an example in code. You'll see what a Windows Docker looks like. Basically, it's like derive from Windows, unzip this legacy .NET application, start up IIS with this configuration, and it'll come up. Okay? So let's say that this is a use case from TrendMicro, all right? And TrendMicro, they do threat detection, right? They have virus software, and what they want to do is to report incidents to people. I like showing this example to folks. They're like, oh, I'm a web developer, right? I make web portals. I make APIs. I'm like, that's great, but this is the larger picture of how big companies work. You know, there's a lot going behind big data companies. Even if they're not a big data company, they start to realize there's a ton of information that's untapped. So even if you were not TrendMicro, this same exact architecture could be used. Okay, and I'll explain how. All this is showing is thousands of computers in their whole data center, and all of the people that have installed TrendMicro is sending data using this tool called FluentD to one big Kafka cluster. Then Kafka is a streaming technology. That data gets published essentially and picked up by Spark Streaming and Akka, which is an actor-based reactive technology. And the data gets saved into Cassandra and then restreamed back into Spark Streaming jobs. And if something is detected, it gets put into a PostgreSQL database, which is exposed via an API server, which is then exposed via a web portal. Yeah, sure.
Actor is like a middleware actor.
It is, I mean, you could use it for middleware, yeah. Yeah.
It's almost close to the definition of actor, like multiple actors.
Yes.
Like multiple interfaces, like
Concurrence.
a Spark
Yeah.
server.
Yeah.
So Kafka is what?
Kafka is it's like MQ series.
Okay.
But it's distributed in that it can do a ton of volume. It can do terabytes of data, like per second. Yes. It's not a pure service, but it's a message queue.
SQS kind of thing?
It's like SQS, but you can run it on your own system.
It's open.
It's open source.
Open source, right?
All of this is open.
Everything that you see here is open source, except for TrendMicro. All right. So, I mean, can you see how, like, if you put the right pieces of software together, you can do amazing things with information. So, TrendMicro did not need to create infrastructure. They just needed to Dockerize everything. And each container represents all those pieces of software. And all of a sudden, you have a full-fledged, I don't know if they're in Fortune 500 or Fortune 5000, but that's a Fortune 50 solution, okay, which can be running on your laptop. And your testing environment does not need to have 20 servers or a system administrator managing it.
The only thing that's flowing between is the
Data, that's it. Data and files. That's it.
What is the templating that they use? Is it a flat file?
It's literally like a batch file. It looks like a batch file.
Okay, it's not like a JSON template.
No, it's much easier. Yeah, you'll laugh, and when you look at the syntax for a Docker file, you're going to laugh.
So to simplify,
Yeah.
at the CIO CTO level,
Yes.
right? Because we are like technical, we're very technical, right?
Yeah.
Make it easier to self-host means, they want to implement this new technology in the organization, right? So instead of going to invest in building, you can just get like a Docker file or like an API gateway, one for Kafka, is that what you mean? Like just use it on whatever infrastructure you have on EC2.
Yes. So basically, anything that has an icon,
Right.
that's representing stuff that's already out there as
Right.
Docker containers.
As a container, right, yeah.
Everything's already there. Your API server will be your API server, right? So you may use Flask, or you may use Node.js to make that API, or you may use .NET to make that API server. It's up to you, right? Or you could use something like we have it.
RPG.
Exactly. And actually, they've open sourced that. It's
Really?
so Kong. It's called Kong. It's an API gateway.
KONG?
Yeah, KONG. All right. And then the web portal is whatever you use. Yeah, go ahead.
Is it possible to have containers inside of other containers?
Yes,
So people,
you can. And in fact, the micro is something called a micro container. It's a very, very lightweight operating system where everything itself that runs the operating system is running in containers. Yeah, and actually, there's something called Minikube with a K. And normally to run Kubernetes, you need physical servers. What Minikube does is it actually runs multiple Kubernetes nodes in one big one. And then you can start to play with Kubernetes in one container.
Kubernetes is what, like the visualization thing?
No, I'll get to that in 1 second. He had a question. Yeah, go ahead.
You said docs are usually wasn't the interaction between all the containers and infrastructure?
No. Infrastructure is everything that is generally static.
Okay, like physical.
Physical, well, no, not physical infrastructure is static, but this is like more of a soft infrastructure for basically the structure of your whole system.
Yeah.
You're taking something that would have been in hardware and you're basically making it digital.
Yeah.
It's all code. You can define the whole thing in code.
To go back to this point, solving this to CEOs and
Yeah.
managers is that saving money because you're not standing up the server every time you want something to do infrastructure. You just stack from
Yeah,
software level.
the time to market,
Right.
the go-to-market strategy, and the time to market they affect each other, right? If the R&D takes 6 months, the go-to-market strategy is okay. Wait 6 months before you go to market.
You have Six Sigma approach. That's what you say.
Yeah,
Six Sigma, literally you have Six Sigma if you get your services right.
yeah, it can be, but like everybody has to be trained on it.
Yeah.
The systems have to be in place so that everybody can basically use containers, right? That's what we do here. Every technical person has to know how to use Docker, because if I want to help them, I'm not going to go to their computer. I'm going to say, make sure code is committed. I'm going to pull it down. I'm going to run it. Think about that from a virtual standpoint. If there's virtual team members,
Do you guys use like Vagrant to have like
we don't even use Vagrant. Everything is in Docker.
oh, okay. So how do you make sure your development environment is the same across if you want the same thing?
The Docker container has all the dependencies.
So you have like a Docker container you use for that.
Yeah, there's a Docker container for building, Docker container for testing,
Okay.
Docker container for serving. Everything is like it just that's if you think about it purely in Docker,
I like that. Okay.
you don't have to worry about Vagrant or Homeless. That's a new technology called Homeless. No. I'm just kidding. I'm just kidding.
You lost me on that.
No. We make fun of like technology names here. There's a technology called Purple Almonds. Have you guys heard of it? No, there's no such thing called Purple Almonds. But there's one called Zookeeper, right? And Hadoop.
Yeah, Hadoop, yeah.
And then there's like
Grunt.
Grunt, right? So we make fun of names all the time.
Great. Like forward.
So the testing containers, so they have their own configurations.
Yes.
All the containers are-
Yeah, you can have a container that runs Jenkins, and then derive it to say run these tests on Jenkins. Okay.
So where are we going with that type of market thing?
Yeah. So basically, what would have taken to bring up this infrastructure, clustered infrastructure, with even virtual machines, to write the Terraform scripts on EC2, even if you use something like Terraform, it would take a week, maybe 2. Okay, this could be done in a day, and like working. I mean, maybe everything except for this. All right, like the dev team would be ready to go on day 1, basically.
So there's no cost savings, it's basically time.
Oh, there's cost savings too, because your developer team does not need any external hardware to start working today.
Right.
It could be on existing dev machines.
And also the time, the money you pay for the developers to do the job.
Right. Yeah, there's time and money for sure on both of them.
One quick one.
Yep.
Can I create my own customized image from a vendor's image?
Yes, that's exactly where I was saying. You can derive the image
Okay.
and add what you want to, and that's your image.
Sorry, I
Yep.
missed important things.
No, that's okay.
Right, so you derive it and then you put stuff.
When we do the hands-on stuff, you will clearly see everything that we've been talking about so far. Okay, so this is what a Docker file looks like. This is actually a compose file. All right, and a compose file basically has run Kafka. Where do I build the image from? Well, I can say just run it from this one directory, and in that directory I'll have a Docker file. Run it on this port. Okay, Spark. I don't want to build Spark. I want to just use the Spark image that's already published. So you can use a combination of published images and make your own. They never have to see the light of day outside of your hard drive. Okay? But the benefit of publishing an image is that it can be leveraged elsewhere. And if you are not comfortable with basically publishing your images to the public Docker Hub, you were asking that question earlier, right? There's GitHub for code. There's a Docker Hub for Docker images. All it basically does is store the build of that image.
So you can have your own JFrog repository.
Exactly. So Docker sells that service. If you pay for Docker Cloud, you're basically saying, I want private repositories for my images. Or you can use some other software, other companies that do it too. Or you can run it internally. You can run your own Docker registry on Docker in your hardware.
On another Docker.
On another Docker.
What about the patents with the property right, copyright issues relative to stuff put out there? So you just handle it the same way that you would handle it now?
Yeah, it depends on what you put in the license.
Okay.
So if you don't want it to be out there, you don't put it out there. You put it in the private repositories. If you put it out there, you say, this is, copy left license or an Apache license. It just depends on what you want.
So what about, so if you put it out there, what about tracking it, monitoring it, seeing who's pulling it down, utilizing it?
So you, just like GitHub, you won't know who downloaded it, but you'll see how many people downloaded it.
Okay.
That's how they track the popular repositories.
Okay.
Okay. We actually will take a look at this voting application. So this compose file basically says there's one app called result app. There's another app called voting app. There's another container which is the worker process. Okay. These basically represent a container. Each of these kind of sections of the YAML file. Again, we'll go deep into how this is working, but your whole composition of all these different services is going to be in one file. And your Docker files will be basically representing each of these images. Okay? All right. So I'm working on this, and parts of this are already Dockerized. So this is kind of my passion project. I always like to learn new things, and this is the open source project I work on to learn cool technologies and Dockerize stuff. Learn how to Dockerize .NET, learn how to Dockerize Node. So this stuff is publicly available. Yeah, if you want, absolutely. Yeah, I mean, absolutely. So the Appleseed repository on GitHub. There's one called Search Stack, and we'll actually use that as an example. It actually Dockerizes MySQL, Elasticsearch, Node.js, .NET, Solr, and Nginx.
So how this data section, right, that you have?
Yeah.
Your distributed computing world, does it even apply anything over here? Do you have a distributed computing section in this?
Yes, that's what when I was covering the Spark. If you have multiple containers, right, you can say for this type of image, I want 10 workers, and it will actually run 10 containers of that image.
So how do you distribute? How do you say one transaction to another transaction? That gets more complicated.
It gets complicated, but what you can do is there's built-in, or not built-in, but people have made proxies. So you can say Nginx load balance this. Okay.
So basically, you're waiting for step one, like a workflow process to complete, and then workflow 2, workflow 3, like in Cassandra.
Right.
The node spin-offs doesn't matter because it internally understands the algorithm.
Right.
So it works on its own.
Yeah, that's the thing. Like you can have an event-driven architecture that basically you have workers that are ready to go, and then it takes a message off of the queue, which is in Kafka, and then continues. Okay, it's as it would be anywhere else, except that instead of using virtual machines, you have this container wrapping it. But containers can come and go. You can scale them to 100. You can get them down to 5. You don't have to wait for the machines to spin up. The machines are already up and running. Okay.
The technology process was threads. Threads are lightweight, process are heavyweight.
They're kind of like threads, yeah. But inside a container, you can have multiple threads.
There's a coarse analogy.
Yeah, yeah. But a container can run anything that a machine can run, right? So, anyways, we're going to take a moment and pause our recording. Let's see if there's some questions here. Oh, awesome Docker. Yeah, so that's actually in my knowledge base. The awesome Docker, yeah, that's one of my favorite awesome lists. I'm going to stop recording, guys, and give ourselves a quick break. And we'll come back to do some hands-on. All right, guys, so we're back from lunch, and we're doing a quick introduction to Docker. We're showing an older slide deck published in 2013. Any ideas why? I know I kind of said earlier, but for the recording.
It was when they first came out.
When it first came out? Okay. It's also because I believe this is by the architect of the software, the person who made it. And so there's a video of it somewhere, but it's like an hour long. We're not going to take an hour to go through this. So they were talking about, so this is 8 months, right? This was 8 months after it launched. There were 200,000 pull requests, 200 people contributing to it. It was popular like literally when it came out. People were like, this is awesome. And already thousands of applications were Dockerized in 8 months. And specifically, this was the challenge that people had. You have all of these different stacks, Redis and Redis Sentinel. That's a queue. User database, which is on PostgreSQL. Analytics database, Hadoop, Hive, Thrift, OpenJDK. Ruby frontend will be Ruby, Rails, SASS, and I don't even know what Unicorn is. API is in Python, Flask, PyRedis, et cetera, et cetera, et cetera. So the stack itself then would have to be deployed to, different variations of hardware. The development virtual machine, the QA server, disaster recovery, like how are you going to store that? For production servers, the customer's data center. If you're going to ship software, not just running on the cloud, you're going to give it to somebody. So essentially, what works on what? In order for you to make this stack for your whole application, you have to bring it up on every one of these hardware configurations. And it's different on each if you don't have something like Docker, right? Because your public cloud can have 20 virtual instances, or sorry, virtual machines, but your laptop can't. Your laptop doesn't have 250. Like your laptop cannot physically hold 16 VMs with 16 gigabytes each. If your laptop is not like a I don't even know what's the max memory a laptop has these days. 64 gigabytes.
Yeah.
Right.
Yeah.
Like the IBM ThinkPad is 64 gigabytes. You can't do that. And even if you had like a big machine, like it would be back in the day when people had Sun workstations to do development. Like your workplace would have to provide you with a massive desktop with that much memory. So the analogy that they're using is cargo transport before 1960 was just like this. People would put stuff in drums or in burlap bags, or they would just literally give you the car to ship. Okay? It was, and it had to go through trucks, cranes, trains, storage, ships, all those different things. It was almost identical. So what they decided was, instead of trying to, basically what they decided was, let's use what the shipment industry used to fix their problem. And the way they fixed it was the container, right? They came up with a standard size that would work. They would put all that crap into the container, and that same container would work on all of these different systems because it was standardized. And I think Maersk is the company that like pioneered it, right? They went down for a huge cyber attack recently, but they're the company that actually pioneered the container. And if we can put whatever we want to run in the container, and we can replicate that container over and over again, then it can run on all this stuff. Right? So that's the matrix solved. Every one of these things is a container, and every one of these configurations of hardware can run the container. You guys with me?
Yes. So it's standardized how power, the SKU, all this stuff.
It only standardizes what the software needs.
Okay.
In terms of other software dependencies.
It also lowers the cost
So
of hardware, right?
standardized
Because
software.
you'll need fewer servers. So,
Yes.
Because more containers, fewer servers. Right?
More containers, fewer servers, less time for bullshit. Ultimately, that's what it is. It's just less time for.
Efficiency high.
I mean,
Productivity high.
I'm going back to the Google. I saw the product manager for Kubernetes explaining that Google runs on containers, and their whole pipeline is like this. All source code, once it's committed, from that point on, the containers are all immutable. Meaning the same code goes to QA, dev, testing, etc., stress testing, to production. And what they say is it's code first deployment, and it's source only deployment. Meaning once it's in the source control, the rest of it is done with containers. There's not a human being building the software. The container builds it. There's not a human being testing the software. There's a testing toolkit. I mean, they do user testing, but that's not what I'm talking about. Okay? If you go to a federal project now, they'll have a person like literally come and download and install some software on 20 servers to test it. And then they'll have a lot of people testing it. But what if you could just run a command and that system is up and running? Or what if the QA person could just say, run the whole thing on my laptop? Let me just test it out, break things, don't care, right? So a lot of birds killed with one stone. So why do developers care? You build it once, and it runs anywhere. Okay, and you'll have access to the slides. Why does DevOps care? You configure it once and you run anything. Right? The software was built. I gave it my data. I configured it, basically. And it ran here, but the same way I can run other software. And there's a separation of concerns, right? The developer, they only care about what goes inside the container. The code, the libraries, the package manager, the data, etc. And the operations person, they just care what happens outside the container, which we're going to learn some commands on. Stop, start, remove, move from one host to another. Right? That's possible with the container. It'll just pause it, it'll move the container to another machine, it'll bring it back up. So in this case, they get a little deeper, but it's like, at this point, it was so old, it's like, they can run anywhere on a kernel that's newer than this, physical, virtual cloud, etc. Run anything. And what is it exactly? At the high level, it's kind of like a lightweight virtual machine. It has an equivalence of a Linux jail, where it cannot go beyond that area of the operating system. It's one operating system, but the container technology just says this is your kind of virtual area of this operating system that you have control over, and that's it. Now, there are some security concerns which basically if one container starts to eat up too many resources, right, What if it impacts other services? Yeah, that's true. It's possible. So what Microsoft did as a innovation is they said you can run the same command, Docker run, and we can run it in the same way, or you can say isolated mode. And what it does is literally creates a VM and runs the container in the VM for you. And that way it's completely isolated. But your tooling is the same. Docker run isolated. That's the only difference. I'm not going to go into this. This is more like related to Linux. But the big difference is virtual machine versus container. The reason I needed to show you this picture is that I needed to clear away your preconceptions of what this is. Okay? So normally there's a physical server, a host operating system, and a hypervisor that runs other operating systems, and it has some binaries for app A and B. This is one version of app A and another version of app A. Okay? In a container, there's one operating system, and app A uses the same copy of the binaries for two versions. App B uses the same copies of the binaries for app B. And Docker is just running there, managing these processes. So immediately you save on space. Look at all the stuff you don't need. Immediately you also save on memory. So the same hardware can run more stuff.
You can say the virtualization just disappeared.
What's that?
The virtualization just disappeared.
Yeah, the virtualization disappeared. You have one operating system. So this is containerization, right? That's the difference. So if somebody says, what is a container? It's like a virtual machine, but without the virtual machine. Okay? So why are they light? They're light because when you run another copy of it, it doesn't copy it again. It just uses what was there. And if you add on to it, it runs still the original stuff, but just your modifications to it. So it's like a source control system. When you make modifications, it just stores the changes. Okay?
This is like a microservices situation that still works.
It empowers microservices, yeah. But
It empowers, or it is microservices?
So a pure microservice, by definition, is something that does a single thing, right? In this case, in one container, you can have multiple things. Like you can have Mongo and you can do MySQL if you want, exposed by an API. That would be a microservice. Or you would say, my idea of a microservice is one API, one table, for example. So it empowers microservices.
I think microservices can capture the data within itself.
Yep.
So now I can see the exponential advantage of microservices with Docker, which is close.
Great. You can have 50 services and not have to worry about the build process.
And then you can scale a single microservice, not worry about the rest of the microservices.
Exactly. So here's a scenario. So for one of our customers, we have one Docker build for the whole ETL framework. All of the connectors are in there. But when we instantiate one of the containers, we say, hey, container, just run the connector for Salesforce. And it does its job and goes away.
Okay.
Hey, container, come up and just run the connector for BigCommerce. It comes up, does its job, and goes away. Now, what do you mean does its job? It gets the data and dumps it into S3. Then a later part of transformation or translation of the data, we have say, hey, Docker container, come up, take the CSV data we dumped into S3, load it into a data warehouse, and then it goes away. The same build, the same Docker container, we have all the binaries in there, but we're literally using it as an execution engine. Okay? And the next version of the ETL framework, we just have to push out one build. So you can use containers in different ways. Now, the other cool thing is we can run all of those commands simultaneously. We could run 50 versions of the same Docker container doing different parts of the framework, but it's one engine. Okay? You guys still with me here? Okay, good.
Right. Okay, so the image, the Docker file, is that what you're executing? Is that what you're executing?
No, the Docker file is the instruction for the build process to make the image.
Oh, okay, that's just to make the image.
Yes.
Okay, so once you have the image,
Yep.
you do your Docker run
Then it runs it as a container.
as a container. Then the one you were saying do different things.
So when you run different containers, you're basically running different instances of the same image.
Oh, so it's the same image, but how do you get the different instructions for it to do?
They're like processes, right? So you can say, in this image, run this command. Or sorry, in this container, run this
Where
command.
do you tell it to run?
You can say in the command line,
Oh, okay.
Docker run,
Mhm.
and it'll be running
Run this job.
to run this job.
Okay. That's how you. Is that the only way you can give it instructions to run?
No, you can log into it too. You can go into
Log
interactive.
into it?
You can go into
give it a file to run it from? Or...
Yeah, I mean that's what I was doing with my example. I gave it my data and it ran it.
Okay. All right.
Right? Okay. So the basics are this: you have a Docker file, okay, in your source code repository, and the engine will basically build it as a container and then push it to the registry. So far, you're using the public Docker registry. Remember we talked about the registry? You don't have to use a public registry. You can use a private one. John was having trouble earlier because he installed the Docker Toolbox for Mac, and it basically asked him to log into the registry. Well, the benefit of that is now you can get access to some of the private registry images that you would not have been able to get to publicly. So there's some security built in, meaning you can't just randomly, let's say you're a software vendor, right? Let's say you're a software vendor like DataStax. You publish your own Docker images, and you allow only your customers to log in and download and run your software. But the customer doesn't have to download anything. They just have to say Docker login to this registry, and then once they're logged in, they can say run DataStax Ops Center, run DataStax Cassandra, and it'll magically work. Okay? So then the host, where it runs, when you say Docker pull, it downloads it.
Okay, that's when it pulls that image that you built
Exactly.
out of the repository.
Exactly.
So the container A, it's an amalgamation of Docker file
And the source code.
Okay. Oh, and the source code and the host OS.
No. It doesn't need a host OS. It assumes that the host OS will have the same, basically, kernel, like a Linux kernel or a Windows kernel.
Okay. So then I get what you're saying.
So Docker file is the instructions to build a container.
Right. And then the Docker engine, it just sort of, I don't want to say it takes a snapshot. It just sort of.
It is like a snapshot, and you're getting to it, yeah.
It just takes note of all the characteristics of that OS.
Yes.
In order to inform the source code as to what it's.
Yeah. So this is what it does. Every command in the Docker file is a change to the operating system. So if you have a Docker file that you derived from, right? It's basically a change to that original Docker file. It's literally, that's what it is. Docker file on Docker file on Docker file. Okay? It's just appending it. But instead of appending it and making a new image every time, it has a cache of those changes as an image, as a binary. Okay. Right? So when you add your stuff to it and you change one line, it checks, did something change? If it changed, it deletes that area from the cache and adds another binary. What the registry does is it keeps the binaries cached so that your computer doesn't have to build it every single time. The binaries are kind of like compressed. It just says get it, okay, and use it, exactly.
What cache is this?
Oh, this is the internal Docker image cache.
Okay,
Yeah, it's an internal thing. It just keeps it.
But this is from Linux to Linux. But what if you say go from Linux to Windows? How does this handle this?
So right now, the gentleman here with Windows, they are using something called boot to Docker, which is a Ubuntu ISO running on VirtualBox. It's a virtual machine.
Okay.
Running Linux. That's how it's working. Okay, and vice versa. The way that they're going to get Windows Dockers to run in Linux is a compatibility layer, essentially. But yeah, your host operating system has to match, essentially.
The destination.
Yeah. Okay.
What's the extension of a Docker file?
What's that?
The
extension of the Docker file.
It's just Docker file with a capital D. Yeah, I mean you can. That's the default name, Docker file, with a capital D. And if you have that as the name, then when you say Docker build dot, it will find Docker file and do it. If you name it something else, you have to say my Docker file is this. Okay. So when there's a change, okay, only the change gets shipped to the registry. It doesn't rebuild the whole thing. So what do I mean by a change?
Modification.
My derived image, for example. That's one type. Modification. Okay? And then every other engine that is subscribed to that registry, if I say Docker pull, it'll check to see if I have the latest version of that thing, and it'll just replace it. All right? So at this point, back in 2013, people were already starting to support it. Okay? And I'm not going to go into the use cases. We kind of talked about use cases, but that was my kind of, going back to the roots of what this all is about. Okay? So you guys kind of grateful we went through that? Does that clarify what a container is, what an image is, what a Docker file is? Okay? So let's do a quick quiz.
Can you share that?
So that presentation, as I mentioned, is in the Introduction to Docker knowledge base page, and it's the second link right here. Okay, and if you can't, and I'll help you with the knowledge, getting the knowledge base up and running, but it's also on the actual repository. If you go to the root, go to content, go to Docker, and Introduction to Docker, it's right there. Docker Intro Classic. Actually, if you just go to the repository and look for a classic, I think that's the only thing. Yeah, there it is. You'll find it. Okay? All right. So let's do a quick assessment to see where people are. What is and actually I'm going to pause the recording for this bit.